Hello, my name is Aaron Pena, and this is my Math Praxis final project. I am presenting findings from a practitioner inquiry conducted in my eighth grade geometry classroom. So during our transformations unit, I closely analyzed how students' discourse revealed their geometric reasoning. The study helped me better understand how students make sense of transformations when they verbalize their thinking. My goal is to investigate how students talk, both informally and formally, how it supports geometric sense making for them. Throughout the unit, I noticed that discourse played a huge role in showing what students truly understand about transformations. So I wanted to outline the broader purposes of the study. So in my classroom, I saw that students often had correct answers, but the explanations definitely revealed gaps. I wanted to look deeper into the how they reasoned, not just what they answered, which is, it's fundamental to close those gaps. I also connect this work to my reflective teaching practices, since this project helped me refine how I guide students talk to support conceptual understanding. So the focus and the foundation. Of course, um, these were my guiding research questions. As an eighth grade math teacher, I observed students explain transformation using visual descriptions. They use gestures or and the algebraic or coordinate rules. I wanted to understand how these forms of discourse helped or limited the reasoning. I also investigated how my students used visual and coordinate representations when explaining transformations. So my primary research question was how do students explore how students discourse support geometric sense making during instruction on transformations with a supporting uh, standard or research question asking how do I investigate how students use visual and coordinate representations in their geometric explanations. So that was the core of focus of the presentation. I then synthesized, of course, key ideas from literatures, which I referenced at the end. Research on mathematical discourse emphasizes justification over description and the development of social mathematical norms. I used work from Hollebrand's. It showed that the students often begin with intuitive visual understandings of transformations and need guidance to connect these to form geometric properties. NCTM also stressed connecting multiple representations, which became central to my analysis of students' explanation. Research method, because this it was a classroom embedded study, I relied on naturally occurring data. It allowed me to analyze genuine student thinking and the flow of the instruction. So for my data collection process, I drew from three main sources. One, the reflective teaching notes. Two, exit tickets from students, where students then justify transformations. And of course, students' work samples, including coordinate grids and written explanations. The sources were authentic and aligned naturally with the tasks in my transformation units. They gave me strong insight into students' reasoning patterns. My analysis process included using thematic coding to identify patterns in student reasoning. My A priori codes came from research such as visual reasoning, naming without justification, and coordinate based reasoning. My inductive codes arose from the data such as the parameter confusions or partial invariance. Through the process of memoing, I then refined code categories and synthesized them into three themes. So my key findings from the analysis, each theme that I said I characterized them reflect the major pattern I saw across the exit tickets, the work, and the discourse happening in the classroom. So theme one included students overwhelmingly relied on visual reasoning at the beginning of the unit. They described transformations in terms of what they saw, movement or alignment before using properties or parameter. So my role became helping them transition from the intuitive descriptors to precise mathematical explanations. Theme two, it was students often knew the name of the transformation, but struggled to justify why it was correct. So, for example, when they knew something quote unquote flipped, but couldn't yet articulate that it involved equal distances, perpendicular bisectors, which is not really something that we discuss in eighth grade, but they should have seen that it was perpendicular because they do deal with angles or preserved properties like congruency, orientation of the figure, and which the orientation of the vertices might have changed in a reflection. So through discourse, routines, and questions like "How do you know?" students began adding more rigorous reasoning. And of course, we go back to the culture. I let them explain in their own terms, discuss it with each other, and then try to probe the actual academic vocabulary. So it's the scaffolding, right? That was super important in the discourse. So my third theme was when students began using coordinate rules or the algebraic representations, their reasoning became more structured and definitely more precise. Expression like x plus 3 and y minus 2 helped them justify transformation systematically. It helped connect diagrams to coordinate rules. It proved especially powerful for my multilingual learners and students who relied heavily on visual cues because now they actually see, oh, what am I doing to the x coordinate? I'm adding 3 to them. What am I doing to my y coordinates or my y values? I am subtracting to. So they're moving down, they're translating down, whatnot. And I'll shift into my instructional implications. So here's my reflection as the teacher slash researcher for this project. It definitely helped me notice how valuable student discourse is. I know it's something that my school district itself has been implemented. They call it the talk a little, talk a lot. In other words, the teacher does a little bit of the talking and the students do a lot of the talking, right? So I learned to intentionally build norms around justification, support visual reasoning as a starting point, and create more structured discourse opportunities. I also gained insights into how to support multilingual learners, especially like using the sentence frames and the visual scaffolds, having a coordinate grid, having them start there, and then start talking as to what is happening in our transformations. And here are my conclusions. So, student discourse offered a deep look into students' conceptual understanding. Analyzing their talk helped me adjust my teaching to support clearer reasoning and stronger explanations. And here are the references that informed my research. They definitely guided my understanding of the discourse, the geometric reasoning transformations, and effective instructional practices. Thank you very much. Thank you so much, Professor, for all the guidance that you have given us over the past 7 weeks. I truly appreciate it, and I hope you enjoyed this presentation. We'll see you all later.